room. I always love this venue. Thought it actually it's good. It's not more crowded. It's a little humid here today. Let's see. I got it. Recorded. Okay. Working with ocean models in the age of agentic coding. I put my name on here with my affiliation just because I think one of the flyers that went out said USGS, and as you heard, I'm no longer at USGS. That took about 2.5 years ago now. I retired when I turned 62, but I retired from the USGS. I didn't really retire, although I do have a shirt that says like retiree. I've been working like a third to like half-time for my one-person company, Open Science Computing LLC. And it's really working with a couple of these clients that I have been really appreciating agentic coding. And so I think Chris sort of suggested I come down here and talk about sort of how I have been using agentic coding. And I know that there's other people who have been using agentic coding, and I encourage you to chime in with like, what your experience has been, or if I say something that's wrong, or, if you want to clarify things or whatever. We're all learners when it comes to agentic coding. It's only been around for a year, and it really became super popular like in October. And I didn't really find out about it, or really I had heard about it, but I didn't really jump on board until about February of this year. So just real briefly, the two clients, or the two main things that I do in my little company. One is I'm a consultant on this Post-Predict project. This is a European led project. Where they still care about science and they have funding. So it's really nice. And their goal is to basically do everything. Like it's Nadia Canardi is involved, and it's the idea is that you should be able to be in any country around the world, and you're concerned about climate, how it's going to affect your coast. You can get some low-cost sensors, throw them in the water to assist whatever measurements are already being made. You can spin up a coastal model that's nested within other regional models that they have all hooked up, and then you run your model in a Docker container on the cloud. The data goes into a cloud optimized format. Actually, I think that's the next slide. So you run your model on the cloud. That way they can scale up to whatever resources they need. Then you rechunk and standardize the output if necessary. Sometimes you just add metadata like do people know what CF metadata is? Like, yeah, no, stuff that makes your model output can have conventions that allow software to work with different models. So you can do that after you've run your model, and then you push your netcdf files to object storage on the cloud. And then we use a Python package called virtualizar that creates virtual references that actually, it's like the byte ranges for all the chunks of data in those netcdf files goes into metadata that then allows you to just read these huge collections of netcdf files by just pulling chunks of data without using like a netcdf library. So it makes it really fast to use on the cloud. And then, the new way of storing those references is you store them in something called Ice Chunk, which was developed by an open source project it's mainly developed by Earthmover, which is where Ryan Abernathy, who used to be in the Stangio ecosystem, which I talked about last time I was here, probably at 5 years ago or something. They're now a lot of the best people in our field, Deepak Chur and a bunch of other people a lot of the best tech people in our field went to work for that company, but they're releasing open source software. Anyway, Ice Chunk is a way to basically have like a GitHub-like repo for your model output or other big data sets. And when new data comes in, there's a new commit, and it gets it comes in, it gets assimilated into the same data set. So users can just keep getting the same data set, and as the new data comes in, it's no problem. And then, but you do have to update like the catalog. So we update like the end time on the catalog entry for that data set to indicate the new forecast extent. And then with the users, if they're using Python, they can do a query to the catalog, find items that match their geospatial temporal variable constraints. Then they open up that asset as an X-array into X-array from the Ice Chunk repo. And so you can do that with pretty much any big data. And then this is kind of new, as this was enabled by agentic coding construction of this JavaScript library that works with Ice Chunk and ZAR data sets as well on the cloud. So you can you can now go directly from your browser to the data if you want to bypass Python and any kind of servers or anything like that. If that's a viable route. Anyway, this whole thing is kind of what I go around teaching people who want to provide a lot of data. I teach this whole thing, and I spend 3 to 5 days, and I talk about X-ray, and I talk about Dask, and I talk about virtually czar and all these things, stat catalog. But it's kind of complicated to learn all that stuff, and then when you really all you want to do is take your own data set and like get it served. Like, why do you have to learn all that crap? I mean, you have to know what you want to do, but nowadays, like, I can just tell people to use an agent, point them at some workflows that already exist, and they say they have a little interview with the agent, and like, what do you want to do? Where is your data? Is it open? Are there credentials that are required? Blah blah blah. And eventually get a workflow. Yeah.
I'm really sorry. I came in a few minutes late, but so when you say an agent, is this like an AI thing? Or you're actually speaking to someone like Rich Signal?
Yeah. No, yeah. So what is an agent? Good question. So the point of having this an agent, and I'll get to the difference between agent and chatbot in just a second. But forever, right? We've done too much time coding, debugging, reformatting, blah, blah, and learning what the weird API is that somebody provided for their data, all this stuff. And it's just all, I think Ryan Abernathy calls it toil. It's a good name, toil. So we're trying to reduce the amount of toil and spend more time doing what we want to do, doing ocean science, doing creative things. And we don't want our creative things to be limited by the fact that we just know MATLAB or we just know Python. We want to be able to do what we want to do in whatever, and just do it. And we want to direct how it's done. We know what we want it to do, and we probably know how to test it. And these agents can just create all the code. So this is what makes, we've been using chatbot. Like, how many people use chatbot? Everybody, right? Oh, okay. Yeah, I mean, there are moral issues. I'm not going to talk at all about how much it costs and about any of that stuff. I'm just going to talk about how to use it for oceanography, and you can decide for yourself, like, whether you want to use it or not. And so the difference between the chatbot, you ask a question and it gives you back an answer. And so you say, hey, can you give me a piece of Python code that reads this weird CSV file or something, or a CSV file? It creates a little piece of code. So then you cut and paste the piece of code into your Python environment, and you run it, and it didn't work. So then, like, you copy paste the output back into your chatbot, and it goes, oh, okay, do this. And so you cut and paste that, And so that's stupid, right? That you are the machine. You're just like a monkey, just like cutting and pasting. So, so basically coding agents, the big deal is they have these loops, these feedback loops. So you tell it what you want it to do, it writes the code, but then, like, you typically use these things in a terminal on your computer, which seems like, ooh, a terminal. But it's like, hey, that terminal. Hey, that's it. So anyway, you run this in a terminal, you say what you want to do. It generates the code, and then it runs the code, right? It runs the code, and then when it bombs out, it analyzes the error and it goes, oh, I think I see what's going on. Okay, and it changes the code and runs it again, and you can interact at any of these points, So that's a big deal, right? So, and it can also understand code, like, so you have some code repository, you download this thing, or maybe somebody gave you some complicated code or a collection of programs, or whatever. And it can look at them and figure out what they're doing. So if you just get some pile of stuff, you can have it explain to you, like, what these various things do, because it can read code and understand what the code is doing. So, like, I just remember I'm going to go off topic a few times here. But there was a guy we worked with in IUS who, we say, dude, this code is like totally undocumented. He goes, well, it's a waste of time doing documentation. Just read the code. The code tells you what's happening. And I was like, oh boy, okay. That's some tough love. But now the agents can do that. The agents can read the code and figure out what's going on. So that's awesome. So they can help you understand things. They can do this feedback loop thing. And they can they can also write code, like Okay, so these things also use LLMs, and the LLMs have been trained with all the data that came before, so they know already how to do all sorts of stuff. Like, you know, when these agents figure out, like, you wanted to do something with Git, it already knows everything about Git. You want to do something on Amazon, it understands everything about the Amazon ecosystem. So you can just say, hey, agent, like, create a machine for me on Amazon that has a website that does this, blah, 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 whatever. And it will just create all that stuff. Oh, and by the way, make sure that I can also destroy it at the end, you know, and it'll just create all that code for you. You can run the code, it deploys the thing on Amazon or whatever. I mean, all that stuff that we used to have to hire like a guy that we couldn't afford to go do that stuff for us if we wanted to. Like we paid at USGS, we paid a guy $300,000 a year to do that kind of stuff for us. Well, we cost us $300,000. So that's, you know, so one thing that the agents already know how to do is they know how to use these command line interfaces, all sorts of things that are out there that provide data and services on the internet. So like OpenDAP, like for us, or you know, ERDAP and curl, you know, downloading files and all this stuff. And it also understands all these different kinds of file formats. It's seen it all before. And that's not different than a chatbot, but so it knows a lot of stuff. So, and then if you want, like you have something where you have some specialized thing that you want to let people interact with an agent with, you can develop something called a model context protocol, an MCP server, where you specify specific tools that the agent can use to interact with your data or services or whatever. So there's these kind of two ways of doing this. And so now I'm just going to actually show you a little demo. And I'm going to do a demo where we use, how many people know about ERDAP? Heard of ERDAP? Yeah, most people. So it's like it's been around for 30 years or something. And it's where NOAA stores, and other people, lots of people store like typically sensor data, some remote sensing data, but like NOAA had all the NOAA WHOI data is there and stuff. So they developed a MCP server for ERDAP that has like these tools, like so you can, if the agent can just go request this tool and it'll list all the servers, like there's all these different ERDAP servers. So like anybody can deploy an ERDAP server, like Miracus has one, and NOAA CoastWatch has one. There's all like, I don't know, hundreds of these things probably. And then so you can list these servers, you can search over the data sets, you can get data set info, and then this is a bad name to pandas, but what it really does is give you data back from a data set, like CSV data, JSON data set. Data that an agent can just work with. So so now I'm gonna just pop out of this. This should still be visible, right? And okay, I'm gonna make this a little bigger. Can you see that in the back?
Yeah. Yeah.
Okay. My office is okay, then why not one more? Control this. Okay. So I'm in Claude here and I'm in a terminal on my Windows computer here. I'm using Windows subsystem for Linux, but you could just use Windows if you wanted to. I've got Claude open and I just say where and when were the biggest wave heights in the Gulf of Maine this past winter. I'm not going to run this live because actually each one of these queries does take like 20 seconds, 30 seconds, may take like a minute or something. So this whole thing probably took 8 minutes or something. I don't want to do that. So maybe we'll do a little live stuff at the end if we have time. But so then it comes back, the little dots are the agent talking back. So it says, I'll look for wave height data in the Gulf of Maine using ERDAP servers. Let me start by loading the ERDAP tools. The NDVC buoy meteorological data set on CoastWatch has significant wave height. Let me confirm that structure. So then it calls the ERDAP tools two times, and it finds out that there's 40 buoy observations that exceeded 6 meters. It found the peak. Let me pull the highest record. So it's telling you what it's doing, and at any time, you can just hit escape and go like, hey, no, you're doing the wrong thing, or like do something else. But if you like it, you know, and in fact, I think by default, it makes you say yes or no on every one of these, unless you say go ahead and do some stuff. Like go ahead and keep going. So yeah.
How does it know at the beginning to look at the ERDAP server? This is a regular Carl, or it's something else?
Yeah, no, so that's a good question. So I've installed the ERDAP MCP server.
Oh, you have.
Yeah, so you say implied, you say M/MCP. And then there's a web page that on the ERDAP MCP server that says, here's what you type. And so I did do that. And so and what it's doing, it's a good question, because so it sees wave height data, and it knows that there's a lot of NOAA wave height data on ERDAP just without the tools. And then it uses the ERDAP MCP to go ahead and pull the data. So all the top waves, it says occurred on this particular date. And then it comes back, I'm not going to go through exactly all the stuff, but it comes back with this little table, with the wave heights, the buoys, location, the different wave heights and the time. And actually it does, it actually throws in some little stuff that I didn't ask for this, and I'm not sure I really want it, but there are significant wave heights. These are significant wave heights. Individual peak waves would be roughly 1.7, 1.9 higher. Is that right, Steve?
Sure. Whatever it says.
I was asking Elgar.
I was answering.
I know you did. No. So then it says do you want me to, so actually interesting, at this point it has not run any Python code or any code. The agent has just made these tool requests and come back with some CSV data, which it knows how to process, and gave me a little table and some stuff. Then it says, do you want me to plot the wave height time series for that storm? Or why, this is like chat box stuff, hey, do you want to do something else instead? It was fun. Okay, well, plot the wave height time series for that storm. So then it says, I'll pull the full time series and plot for the storm window. And then, it tells what it's doing. The MCP tool only returns summaries, so I'll fetch the CSV directly and plot it with matplotlib. So it's going to do some Python code. So here, then it says, so then it says, okay, well, I'm going to fire up some Python, and I'm going to import the packages I need to run this little script that I'm doing. And then it fails. So it tries to do what it's doing. It creates a little temporary directory, and it creates some Python code. It tries to run its little plotstorm.py that it created, and it errors out. It comes back with this error that it then, there's 3 or 4 lines you're not seeing here, and it figures out, oh, the URL needs to be encoded. This is the kind of crap, right? It drives you crazy. You do it yourself, and you're like, what? This was working before, and whatever. It's got to be encoded. Oh, geez, great. Let me fix the fetch. Okay, and then it runs it, and then it works. And so I'm not going to show you this plot, which ended up in some temp directory. Instead, at the end, it said, hey, do you want me to drop this into a notebook so you can see what's going on? I'm like, yeah, let's see that notebook. So then it says, let me set up the Jupyter tools and create that notebook. This is another thing where I've installed an MCP server for Jupyter that allows me to interact with a running Jupyter server from an agent. So this you wouldn't see this unless you installed this Jupyter MCP thing. But now it says I need to connect to a Jupyter server. Let me see if one is running. Of course, there is one running because I started it up. Jupyter is running with this particular directory. Let me connect, and it's going to use this particular software environment because I've told the agent, hey, whenever you want to run this kind of Python code, use this environment that I've set up that has all these packages in it. I don't want you to go figuring it out on your own every time. And I'll get to that a little bit later. So let me build out the notebook, blah, 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 blah. I don't have to go through all this. And then it finally it just went and ran it. Sorry. Okay. So let me, what happened? Oh, actually, this is kind of interesting. So it goes along and says, now let me add a plot cell. Let me add a wind speed section. The wind speed panel confirms the forcing, but the buoy colors don't match the panels. Let me fix that with a consistent color map. Now let me rerun the affected cells. The notebook reflects consistent colors. Done. The notebook is boom. Now, it didn't just build the notebook. It ran it from top to bottom. And so if we go and look at it, should be here. So this is the notebook that it created without me doing anything. It just did this all itself. And so this is The notebook, as you can see, is already run because it ran it. But it's actually, I mean, this is what I would have done, actually, if I would have coded this myself. It knew about this tool that's used in Python to construct these ERDAP requests, so it connects to the server. And this is all like very understandable. This is not just slop, right, that you can't understand. There's a data set ID, what variables we're going after, the latitude and longitude time constraints, and it comes back with some data. It finds the storm peak. Now, I just want to point out that, like, you'd have to know some stuff to know that you could take a variable and do a group by station, and then request the variable and do the maximum and sort the values by ascending. Like that requires some knowledge of this particular piece of software, right? But you don't have to know that. Like you can have this example and go like, oh, okay, well, what else could I do? And this too, like, location where the wave height is this IDX max. These are like things that, like only a few people, it just took you time to learn all this stuff. And therefore would, when you think about something you might want to try and scientifically, you might go like, well, I don't have a year to learn how to do all that stuff or whatever. And I don't have the budget to hire somebody to do this. So you know what? I'm going to do something else. And this is the big breakthrough with these tools, is that it basically allows you to be the creative person that you want. Like, it's perfect for us. It's not so perfect for like some front-end developer who was told to execute somebody else's vision because they're out of a job. But for us, we got ideas. Like, we got all sorts of ideas, the things we want to try. And it's just like your happy assistant who knows all this stuff, not afraid to say that they're wrong. And we know how to test, again, we know how to test stuff, and we know how to tell it how to do the job. I mean, I'm not going to say it's like a grad student. Because grad students are creative. Postdocs.
Frank Turner, say Frank Turner.
So, so anyway, so blah, blah, blah. And, I mean, that's not a plot I would have made, and now you have this, notebook, and this is the start of the conversation, right? You created this notebook, and now you can say like, hey, could you make this like a dynamic like stuff, so I can like hover over and see the heights, like, or can I, I want to see some other storm, or I want to, whatever, right? This is the beginning of the conversation with this agent that's created this note. Well, the beginning was just, seeing what it knew, what it found, and then it created a notebook, and you can go from there, do whatever you want. What time is it? Since I don't have my.
It's 12:40.
12:40.
I want to find, you used an important word, you used the word test.
Yeah.
So in my experience, I find these tools to be very verbose. So they produce a lot.
Yeah.
And so it's really important to test and make sure that you're getting what you think is correct, because it gives you a lot sometimes.
That's true. I mean, but that's also true.
Sometimes to sit.
Yeah, I mean, I think that as like in the beginning, like these tools have gotten a lot better too. Like this code, this is really clean. I mean, this notebook in the beginning, if I asked it to generate like in the beginning, like 3 months ago, you asked it to generate a notebook, and it would be like a bunch of stuff. You'd be like, gee, I just need to pass them. Let me fix that. But it's gotten a lot better. And plus, but for testing though, like you have to test everything, like, right? Like if you write your own code, you gotta test it. I mean, I don't really get that, I think we know how to test things. And like, actually, I was thinking of this example, like Chris at one point, I think early on with the chatbot, he said, yeah, I asked like ChatGPT like for some boundary layer equation or something. What was it?
Which one? I've done a lot of these.
Anyway, it was some.
Oh no, it was one of the test scores. It's like somebody's the Wilmot skill score.
Oh, okay.
That's what it was.
And then anyway, so Chris told me, happily gave him the answer. They gave him the equation, and Chris was like, looked at it and he's like, hey, isn't there supposed to be another term in the denominator? And it says, you're absolutely right. It's another term in the denominator. That's scary, right? But now with an agent though, like you'd say, if that's the equation it came back with, you'd say like, well, compare it to this paper, like compare it, read the data, run it through the equation, see if you get the same answer, or try a different approach, like use another equation that's, and see if like you get, I mean, all the same stuff that you would do if you were actually doing it yourself, in my opinion.
So, but it also doesn't, one of the cool things about it, I think, Rich, is you can also tell it to, as you do with any code, okay, I wrote some code myself, and how do I know I did the right thing? And then you come up with a unit test or some way of testing it independently, and you tell a chatbot to implement that, and so that you get an independent check. It doesn't remove the need to do that, but it actually has the
It makes
ability
it more important.
to code it for you.
Yeah, and actually at the end, like you can set up sort of guidelines for how you would like it to construct code. And I don't know, we're probably gonna run out of time. But you can tell it like whenever you create a notebook or create some Python code, run it, or you can tell it to use like certain stylistic things. You can say, I always want you to test. You can set up whatever criteria you want it to actually always do with certain types of files or whatever on a certain project. You can do it for every project you work on with agents, or just specific projects can have their own sort of things that the agent must do, like or must not do. So there's a lot of power there in terms of being able to kind of not let things get out of control. Although, sometimes things do get out. There's a lot of like learning involved. I mean, I really encourage you to like just try it for a little bit, and you'll find out like, what's frustrating you, and then you pretty much just tell the agent like,
Right.
Hey, this is like, I'm sick and tired of like doing like, why do you keep doing this? And like, oh, okay, well, let's create a skill or a map, something that will not ever do that when you hit that particular thing.
Like at one point, a third of my code was error checking, right? It would get something and then say, if not none, then, and it would say, stop error checking, if it bombs, we'll fix that, but
Yeah.
don't do any error checking code.
Yeah.
That really cleaned things up. So.
Yeah, Gordon.
So this is great. The first step, as you said, get the conversation started. But what can we try next? I'm asking for more.
Yeah.
The next level, calculate vorticity, compare different sides, and
Oh, yeah. I mean, so yesterday I was having a conversation with Tim Crone, and I said, I'm going to try to convince people they should try these tools. And he was like, started laughing. I'm like, what are you doing? Why are you laughing? He goes, well, I have 3 computers running. I have one in my kitchen and one in like, and I've got every one of them is like running these multi-agent like workflows. He goes, I just built an API for my oscilloscope this morning. It's awesome. So you can do any crazy thing you want, like, and so, but you can also have it do, like, if you wanted to say, I want to calculate the transport from the coast mile output that's on Amazon Open Data or whatever. And it's important actually first to do there's /plan. Like, you don't just like tell everything you want to do and just then just hit go. Step by step and create a plan first and review the plan. Because you say plan and it goes into planning mode, and you say what I want to do, and you have a conversation and it creates a plan. You can edit the plan, you can tell it to change the plan, and then you start the work, and you can make it very methodical, like doing testing. You can start off with just tests that fail, and make all that good stuff. If you want, you really, I mean, this is.
How is it with geospatial data?
What's that?
Geospatial data, like pulling tips and making shape files and aggregating.
All that stuff, all that stuff. Like, so there's a guy who just built a full on like GIS in the browser thing with like 4,000 like geospatial tools, like in the browser, like using WebAssembler code or whatever, right? Because he just knew what he wanted to do, and he could point it at all the tools, like from QGIS and from Esri and whatever, and now he's got this, geospatial. It's anything that has been done, which is a lot, unless it's brand new. And even when it's brand new, it can go read the documentation and do, pull stuff from the web and figure it out. Any comment, Joseph?
If you want to try something.
No, I wanted to come back to the
Earlier
earlier discussion,
They haven't been using it.
interacting with the Asian mode. I think what I learned over the time now is that at the very end, it's always good to have some generic
Agentic.
checks. Like I often ask, are you sure?
So,
And then it often comes back to, oh yeah, no, actually I wasn't. Or can you double check or etc. So this is, and it's good about that
Mhm.
to be,
Yeah,
you have to prompt it, but it's good about some self-criticism. And sometimes I run into obvious errors and then tell it and say, okay.
yeah, Yeah.
To do that, but it's important, I think, to, yeah, at least in what I learned in complex coding tasks, is like, double check, go back, and can you write a test? And very often they came back and say, oh no, I missed this, or I missed that, and very often you can really improve that answer quite a
Yeah.
bit, and
Yeah.
find, if you had stopped and not done that, you would have potentially ended up with some really bad code.
Suboptimal.
Yeah,
yeah. And I think, and you can build that in automatically too, if you
Yeah.
want, so you don't forget, you know?
Yeah. right.
But, yeah, then it definitely still, you'll still get some like hallucinations in the sense that, it'll construct some code for doing something. And if you know, like, if you know coding, you can say like, wait a minute, wasn't there like, if you use this other package, wouldn't that have been a one-liner or whatever? And it's like,
Right.
oh yeah, that's it, thanks.
Yeah.
But I mean, it worked, but
Yeah.
it wasn't like could have been done. Yeah. That's
No,
what you're saying.
and one of the things that's also in this iterative process that I learned is you can start out with a simple solution that, in the old days, when we didn't know about X-array matrices, or when you were a first time coder and you write triple loops over some things. You know how to implement and solve something straightforward, but then you can ask the agent, is this most efficient? Or make it efficient, and I've achieved some real fantastic efficiency.
Yeah.
I'm reading H5 data, particularly
Yeah.
with NISAR, with the big data
Yeah.
sets now, with like 35 gigabyte of file. And so that started to be really important, because that would have taken me forever
Yeah.
without an agent.
And it
To
does,
do
and
this kind of sense.
the agent has found several bugs in the well-established code also. That went previously unnoticed.
Yeah.
and also there's,
Oh, Peter has his hand raised.
Yeah.
Okay, well,
Hey, Rich, can I ask, I've been using, this sort of approach for data analysis and also for like real-time data acquisition, also translating code, and, had some pretty good results. But the one thing I haven't done, which maybe you've done, is have you like tried setting up a complete model run? Like say, I want to use ROMs to model the flow in the Gulf of Maine, find the best boundary for me, find the boundary condition and set it up and do it,
Yeah, I mean, I have, and I think that's an interesting one because like part of this Coast Break project is trying, they made a GUI, which is supposed to, make it easy for people to run. It's like set up and run a model.
Yeah.
And it's got something called like, Easy Grid, And so you like rubber bands.
Yeah, I know all those tools are out there.
Yeah, but I mean, but what I'm saying is like, you're right, that because like, sure, it generates you some grid. But then, it's not the grid you want, right? So there's some combination, but I think there's gonna be a really powerful combination of like GUI tools that help you, that are easy to build, because now we have these agents, and also the agent itself having a conversation with you, like, hey, my model blew up. And it'll be like, go look and go like, okay, your model blew up on the eastern boundary. This is probably because, I don't know, you had tides in your forcing, and anyway, some kind of inconsistency or whatever, all the things that can go wrong when you're trying to set up a model will still go wrong. But now you have an agent that has a lot of history and also ability to, do whatever you want to do to investigate the problem at your disposal. So I think it's going to make setting up a model like ROMs a lot easier. And it's going to be like an expert, like assistant. It'll be like, maybe not John Warner or something, but John Warner Light or something. At your assistance, because it knows all the stuff that's been done with Toast before and with ROMs and everything. Like there's a lot of information.
There's a lot of toil in that stuff and figuring out all the formats and stuff like that. So I'm gonna try it with Swash soon. Just do some really simple 1D, run that know what I've done and just say, do what I've done. Here's my inputs.
Yeah. Yeah, I mean, we did, so I mean, as part of this Coast Parade project, I am doing that kind of stuff, but what is cool is that, I didn't near the end, but like, I didn't get through a lot of this, but, that's okay, I got the main stuff across, I think, but let me just skip to one. Actually, what else did we have? Yeah, I mean, so actually, maybe I can rip through this, so one of the things you can do too is like I use this package HV plot all the time, but it didn't really work well with unstructured grid data. Like it worked great with like models like ROMs and HiCom and stuff like that. But if you had a model like FVCom or SciFem or any of the Deltaris, like it didn't work. This HV plot tool that I like. So I don't know anything about HV plot. It's a super complicated code base, but I just like cloned it and I said like but I know that like making an accessor like so that I can HV plot my my unstructured mesh data is going to look a whole lot like plotting curved linear data. The only thing that's going to change is going to be the way you actually create the plot, right? And get the grid information. And so I just told it what I wanted to do, and it went off and it created like this new pull request. And so when I came back, everybody's very sensitive on when open source developers about code that's been developed by agents for good reason. But so I came back, I'm just encouraging you to like put the human back in here. Hey folks, as you can tell, I made this applied code. I've been using it for a few months and I have no idea how well it's going because I don't understand it. I don't want to understand the whole PHP applied code base. But in the end, the developer came back and said, there's a whole bunch of stuff. I went back and forth and I saw stuff I didn't like just in how it looked, right? Like oopsie, I need to include some more parameters. Blah, 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 I made all these different changes. And then, I submitted the request and the developer said, it looks awesome. Took a quick glance and maybe a few cleanup things, blah, 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 and it's about to get included. So there's a lot, like, if these things that you want in certain packages, like you can just like create yourself, or at least get the developers like most of the way there, so that was pretty cool. That's just my proof that it's pretty cool. I can do hvplot.xugrid. Okay, and I can just do unstructured grid variable temperature .hvplot tri-mesh and point. I get my nice tri-mesh plot with that I can zoom in and it re-renders and all that good stuff. 5 minutes real quick. We've had some questions along the way, like just like boring stuff too, like processing my freaking travel receipts, like. I got paid to go to AGU by this group in Bologna, and they came back and they said, we need individual receipts for every time you rode a bike and every time you had a meal. And I was like, what? So I just dropped like all these pictures that I took of my food receipts, and I dropped all the, e-bike things that they sent me by email. And I just said, hey, create some code that like creates all these PDFs that, and then I downloaded my credit card statement, and I said like, and it looked at the pictures and it read the text from the pictures and it figured out what credit card thing it corresponded to, and it added in the and it constructed all the PDFs. Yeah, I was like, and I got my $24, it was awesome. And then I built JavaScript stuff, like I don't know any JavaScript, but and now last thing I guess is just that like I'm using this now when I teach, right? Like the students can do like amazing things. I'm not going to go through this stuff, but these guys got together in groups and created these amazing projects by just knowing enough about Xarray and Dask and all this stuff. And they're looking at heat waves and typhoons all around the world, like, and they knew nothing coming into this class. Do they understand everything that's going on behind the scenes? No, but but yet they have enough that they can start, like, you can ask and learn about these things. You can like use all the notebooks that I gave them as templates to do cool stuff. And it was awesome. They loved it. Except for this guy. Overall, the course was extremely mismanaged and genuinely embarrassing. You were told to use Claude to solve all the problems. The only thing we needed to know is Claude. As an educator, I cannot understand how one would consider this appropriate mindset when it comes to teaching skills. It doesn't teach anything. I do not think the educator should ever teach again until they completely scrub the notion of AI agents as an answer. From every teaching material, they have to go back to real teaching. That guy didn't do anything like that to do with the class at all. So anyway,
And
that
you
one
can
person
figure out who it was. either,
I knew who it
right?
was.
Yeah.
Was that an AI agent?
Yeah, so, anyway, so. I'm not gonna talk about how you can like get in, you'll find out yourself how like these skills and agent settings and stuff like that if you get into it, but I really encourage you to get into it, like, you do have to pay for Claude Code. Claude Code was the original coding agent, but now Gemini, CLI, Chat GPT has Codex, Copilot, they all do like almost look exactly the same. And Gemini like gives you some free tokens, so you can play for free. I just pay $20 a month for, Claude Code, which is like, pays off in like, in my opinion, like the first day. Joseph goes with the $100 plan. Cause he's a big spender.
He's got big data sets.
He's got big data sets, yes. So, but really, I mean, the cool thing here again, is just like, and Tim Crone, I think said his history, it's just like, it breaks down the, like, you want to do something, you're stuck because, you just can't, like, you don't have the time to learn it or whatever. And this just lets you like explore and create and we're not, and I don't think our jobs are in danger except from, from above. But otherwise, though, for creative people, I don't think it's an issue. Thanks.
So Yan Jia, who is working with me, we're working on this Arctic model and combining ROMs and CIC, the CIS model. And then the latest version of this, somebody else developed the coupling. The latest version, the model, the CIC model, version 6 doesn't have open boundary conditions. So the version 5 has, but this particular version 6 doesn't have. They haven't developed it. I'm just curious, are we there yet to ask them?
Yeah.
Oh, I think so.
Sure.
Under
Yeah,
conditions to that.
There's boundary, like the previous version did. And then, that kind of stuff is really, the agents are great at. Yeah.
Okay, we should try that.
Yeah, you should.
Couple of times in the conversation, the topic came up where the human being realized that agent had made a mistake.
Yeah.
So, hey, agent made a mistake.
Mhm.
Agent says, oh, you're right, I did make a mistake.
Yeah.
I'll correct that for you.
Yeah.
So in a sense, the human being has conferred new knowledge to the agent.
Yes.
Is that new knowledge propagated to the agent, just the agent that you're working with, or does that go back into the cumulative knowledge of Claude?
Yeah.
And beyond?
So that's an interesting question. I mean, it depends. Like some of them, like you can say, I don't want any of my stuff to go back to the, or sometimes it asks you, it says, hey, this was like an interesting conversation. Do you mind if like, I take this information and better the world,
Back to the overlord.
But then, so then there's always questions about, okay, so am I just giving this information back to Claude so that like, my knowledge is now boosting Anthropic, or whatever, and not like Google or whatever.
And similarly, are there ways to manipulate that system? I mean, you could teach the agent something that's error.
Purpose,
Yeah.
dash.
What's that?
Yeah.
Hopefully set dash there.
Yeah, for sure. I mean, there's so many, this is like hours and hours of conversation over beer or coffee.
Well, I think what's also quite implicit in your question, and this is that removed even is. What do you actually still need to know to recognize until actually this was wrong? In other words, I think for me, that's the big question now is, what do we teach students? Where do we stand and what do we still need to know? Right. If you throw it, like, okay, you need to know anything anymore because you just ask it in plain language. So I want to do this and that and that. How do we still recognize who is still the human authority who's like, it doesn't look right.
Or how do we even know things?
Yeah.
Right, but a lot of the stuff
Existential
I mean,
questions.
coding is kind of off topic if you're an oceanographer, really. I mean, that's not what you're supposed to be doing when you're an oceanographer. Just like you're not supposed to be doing long division, you should be using a calculator, right? And so it's just a tool like that on steroids, and it's incredible. When I use it, I find that instead of coding for a week, how do I read this file? Where do I get the data? How do I download it? How do I make the plot? Oh, it's the axes on the plot. Instead, I'm looking at the plot. 5 minutes after I thought of, I want to see this plot, and it's phenomenal.
Absolutely. I was seeing in your notebook the axis labels with the LaTeX code, etc. Oh, geez, I don't need to know that to do that anymore. I knew it all. I learned it once, but I'm so glad I don't have to figure that out anymore. Right?
So
Actually, before
No, you don't want to know what I just.
yeah, we do because it's good.
I don't think we have time. It's time to go. It's time to go. My fear is that, if you carry this out, and I'm a philosopher of science deep in my heart, and if you carry this out to logical end, it's a scientist lying in a bed just saying, your thoughts creating scientific knowledge. And I'm not okay with that.
But these things can't do anything novel, and they can't recognize whether.
Right, but if you're saying, what do we need to know? If you carry this out to its logical end, you don't need to know anything other than have a thought and an idea, and the thing makes it happen for you.
Well, maybe that's a big.
That sounds horrible. That sounds
Well,
horrible.
that's a linear extrapolation.
Well, you like-
right?
Well, it's probably gonna go exponential.
No, it could be the non-linear scaling, and then
Might go up a while.
I think it was Dave who.
Brief
sorry.
thought that I think follows up with what you said. I think a big weakness of this that has been brought up in other conversation I've heard, but not this one, is it's very affirmative, and the goal of the agent is to please the user. And so I think in a lot of ways it does manipulate. Like I've been using this the past couple weeks, and really it's like sped up my productivity a lot, I think. But I also find it going, okay, it's making these conclusions and it's interpreting some of the outputs and kind of continuing this narrative that I know I want to tell. And so I've been thinking, critically about like, okay, I'm not necessarily using this part of the interpretation, but maybe this. So I think that's something that should be included.
You can also tell it to switch sides.
Yeah,
And
that's
do
true,
it from the
yeah,
other
that's
point of
true.
view.
And you can tell it to.
But you might not even understand that that it has the,
Well, and that's the question.
there's a literacy issue in that too, I think.
And exploring, and you can tell it to explore alternatives also.
Yeah.
What do you mean by switch sides? Sorry, I didn't.
Well, so if it looks like it's like pushing some idea or sometimes they come off like a yes man, yeah, that's, you say, well, look at the other side, tell me
Right.
what's wrong with this analysis, and we get another ideas.
If you make it think in your first prompt by saying, instead of do this, create a list of 5 ways to do this and give me pros and cons.
Right.
Then you can get around all of that, because then it's no longer biased towards its first answer and wanting to please you, because what is pleasing you is now creating this list rather than just generating an answer.
Right.
And you can get super far with that just by like requiring that it think like a little bit before it regurgitates whatever it's linked up in its synapses.
Got time for one more anecdote?
I
No.
have one, and I think
Go with that.
Dave told me this, David Rocky told me this, and it was a quote from John Trowbridge about being one with the data, is that right? And to me, it's just like, I love everything you showed here, and the ideas of using it for geospatial data sounds great to me, but ultimately, if I'm not in the data, pixel by pixel, point by point, understanding what is going on in it, I feel like I don't feel good, I don't feel satisfied.
So
You can look at every data point and navigate a peak and.
like I just pulled this up as an example. I'm working on a model, super high resolution current model in Woods Hole, like sub 10 meter pixels. And I'm having issues with drag coefficients, right? Because I don't want to blanket drag coefficients. So I'm trying to use bathymetry maps to assign drag coefficients and as well, it's like, I want to see it, of course. So it can just create this map. It's like, here's what I came up with is these coefficients of drag, in certain places where it's sandy, they're going to be low. The issue I was having in the canal, because the canal is kind of weird because like there's a bunch of wrecks down there that are in the bathymetry and it's gravel, but I was, under
Fishing lures.
mostly fishing lures. Yeah.
And it did this by pulling bottom texture data and bathymetry and.
Yeah. And assigning like a roughness scale to it and then using like a Manning to try to get over to like a coefficient of drag. And then you can say, all right, well, let me see it. And like same with when I generated the mesh, like the newest, I'm like a huge Claude user right now for this type of stuff. Like I'm running models that can resolve individual rocks in Red Ledge because I race knockabouts and that's what I care about.
What modeling system is
I'm using Schism right now. But anytime I have it do anything, I show me a map. Like when I was making the mesh, I was like, all right, well, let me see it. And I was like, well, I know there's a rock there. You didn't capture that. Like, then I got to draw that one in. And like that rock's misplaced, or like that gutter is actually wider, or like using LiDAR bathymetry. Anytime you have a bridge, it doesn't capture the depth under the bridge. It just shows you the bridge. Like, all right, we got to carve out that channel. But those things that would take like hours to days before, it's just because, and like I've lived here my entire life. So I can look at this very quickly and say that's wrong. But that ability to like, iterate through that process is just
As a helper, yeah, I get it.
Get it.
Yeah.
Hey, I just want to interrupt and thank Rich and stop recording. I have to go to another meeting in particular, but thank you, Rich, and thank you, everybody in the room for this really interesting conversation and
Thanks,
discussion.
Rick.
Thank you.
Thanks, Rich.